Yeah, good morning. So my name is Isaac Tete, and this is a tutorial video explaining how I did the MSM assignment. Okay, I tried to show my face in a video, but I think when you can't turn the camera once you start the video, so we'll have to do it like this. All right. So there are 4 tasks in this assignment, so I'm going to begin solving the assignment task by task. Right, so let's begin with task 1. So with task 1, the question tells us to provide the set builder notation for the following. So the first question is the set of strings over the alphabet, sigma. So I is the set of strings over the alphabet, sigma 0, 1, 2. That begins with what? 12, right? So the language, we are going to use this set builder notation to develop the language, right? And the format is that the W stands for what? The string, right? So the language of this alphabet is the set of strings belonging to sigma star, which means all input alphabets beginning from 0, giving the condition on that particular string, right? So the language is equal to what? 12W, such that W belongs to what? 0, 1, 2, star. Right. So this means that the string should belong to this particular set, right, with 0 combinations of more, and then the string should start with what? 12, and then whatever combination of 0, 1, 2. So that's the language for this particular input alphabet. Right. Or we can also say that equivalently, we can also say that the language is equal to the string which belongs to what? 0, 1, 2, star, such that the string begins with what? 1, 2. Right. So this is another way of writing the language for this particular alphabet, or the set builder notation for this. All right, so let's move to the second one. So with the second one, the set of strings over the alphabet A, B, up to Z. All right, that contains at least one B. So that contains at least one AB. All right, so this language, we can write it as what? W belongs to what? The set A, B, up to Z star, given that what? W contains what? At least one AB. So that is how we can also write this language. All right, then we move to the next one. I. So it says the set of strings over the alphabet THE, right? So the language can be written as what? The set of strings which belongs to what? THE star, given that the strings has only one occurrence of THE. All right. Then we move to the next question. So IB. Alright, so the IB says the set of strings that accept positive integers that are odd. So we want to develop a set builder notation for positive integers that are odd. Alright, so we can say the language 4 is equal to the set of strings that belong to what? So let's call the set of positive integers that are odd D, right? So let's say D is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we can see that L4 is what? Strings belonging to D plus, okay, such that the last of the string W contains what? 1, 3, 5, 7, and 9. Right, so this ensures that all our strings are what? Positive integers that are odd. So the last digit or the last of the string should be what? Any of these numbers, right? So we can take some few examples before we continue to the next question. All right, so for this one, you can have strings such as, so examples, you can have 1, 2, 3. It ends with 3, so it is a positive integer that is odd. You can also have 1, 3, ends with 3, so it's a positive integer that is odd. We can also have 4, 5, 7. It ends with 7, which is here, so it is also a positive integer that is odd. Over here, you can have examples such as 1, 2, 0. We can also have 1, 2, 1, 1. So these are examples for language 1. For language 2, we want the string that contains at least what? 1 AB. So an example can be what? A B B, right? So since it contains a copy of what? 1 AB, then this string is accepted. All right, then this one has only one occurrence of what? D. So I can have E. So example will be what? E H, then we have T H E, then T T E. Right, so since it has one copy of there, this string can be what? Accepted. So this is the first part of task 1. So we are moving to the B part of task 1. So for the B part, we are to construct the DFAs for the following languages over the alphabet XY. So the alphabet is X, Y. Now the first one, we want set of strings that end in what? XY. So set of strings that ends in XY. All right. So to start building, we are going to need a start state, and then we are going to need what? An accept state, because the set of strings must end in what? XY, and should be accepted by the DFA, right? So we are going to use Q0 as our start state. We are going to use Q1, state Q1, and then we are going to use state Q2. So Q2 will be our current string that ends in X, and then Q2 becomes what? The current string that ends in XY, and it's what? Accepting. All right, so let's draw the DFA. So we start with what? Q0, Now, because we want the string to end in xy, when I give q0x, it should go to what? q1. And then when I give q1y, it should go to what? q2, which is what? An accepting state. So now that we have our accepting, let's look at what we can do with the rest of the string, since the DFA should be defined for every input. So q0, we've already given q0x. Now when we give q0y, what should happen? So when we give q0y, it should loop, right? So y will loop. q1, when we give it x, it can also loop because the string should end in what? xy. So if q1 is x, then xy is accepted, right? So q1 can also loop, so here will also be x. And then when we get to q2, so we have given q0 y and x, we have given qy x and y, so we have to give q2 also x and y, right? Now since it should end in x and y, when we give q2 x, it cannot loop, right? And when we give it x, mean it can end in xy, so it can come back to q1, so that if I have x and then another y, then xy can cause the string to be what? Accepted, right? Now when we give a y, we can't have yy, right? Yy is not accepted, so we can't go back to q1. It means that we have to come and start again at what? q0. That is the y. So this becomes our DFA for this particular alphabet, okay, or the set of strings that end in what? xy. And then we can do the transition table. So the transition table. So for the transition table, we are going to need the what? We are going to need the transition function, and then we have our input alphabet. So we have x, and then we have y, and then we are going to have our state. So we have our q0, we have our q1, and then we have our, so this is not a start state, right? Sorry, this is not a start state. And then we have our q2, which is what? An acceptance state. All right, so q0 on input of x goes to what? q1. q0 on input of y, it loops, so we stay at what? q0. Now q1 on input of x loops, so we stay at q1. q1 on input of y goes to what? q2. And then q2 on input of x stays, comes to what? q1. And then q2 on input of y goes to what? q0. So this becomes our transition table for the first one. All right, so the second one is to do the set of strings. Set of strings that ends in xx. All right, so let's build the diagram and then we'll do the transition table, right? So what we'll do is we'll start with q0 as usual. So our start state is q0. Now on input of x, it should take us to what? q1. And then on input on another x, it should take us to what? q2, which is our accepting state, right? So now we have this DFA that accepts what? xx, and we want it to end in what? xx, right? So it means that we can't loop on q2, right? So q0 on input of y should loop, right? So when it loops, it can loop as many times as it can, and then once we get xx, it goes to the what? Acceptance state. Now q1, when we give it y, it can't loop because we can't accept what? yx. Okay, so y means it has to come and start from what? q0, right? And then q2, the same thing, we can't bring it here. Cool. So when we give it y, it has to come here. But then when we give q2x, since the string can end in xx, q2 can loop what? x, right? so that when we have xx, it will what? Accept it. So let's draw the transition table for this particular DFA. All right, so we have our transition function here, and then we have our input alphabet, which is x, and then which is what? Y. We have our start state, which is q0. We have our q1, and then we have our accept state, which is what? q2. So q0 on input of x should take us to what? q1. q0 on input of y should loop, so we have q0. q1 on input of x should take us to what? q2. q1 on input of y should bring us back to what? q0. q2 on input of x should loop, q2, and then q2 on input of y should bring us back to what? q0. So this is the diagram and transition table for the set of strings that end in what? Xx, giving our alphabet, which is what? X, Y. All right, then let's move to the last one. So the last one, we have the set of strings that ends in what? Y. Right? So we are going to use a similar analogy to how we did this one to do this one. So as usual, we are going to start with what? q0. Then on input of x, we want to accept what? Y, right? Given the alphabet. This is the alphabet, right? So x, y. So we want to accept what? Y. So when we give q0 y, it should go to what? q1. And then when we give q1 y, it should go to what? q2, which is what? An accepting state. So already we know that this DFA is accepting what? Y, right? So now we need to cater for the other input. So q0 on input of x should loop so that we can have any number of x's, and then once we get y, it is what? Accepted. Then we move to q1, right? So q1 too, once we give it x, we can't have xy, so we can't loop, so you have to bring it back to what? q0, right? Then on input of y goes to what? q2. Now q2 on input of y can also loop because the string can end in what? Y, right? And then on input of x, we can't bring it to q1 too, because that would then make it accept xy. So we have to bring it back to what? q0 on input of x. Right, so this becomes the DFA diagram for the set of strings that end in what? Y. So we can do the transition table for that one too. So we have the transition function, we have our alphabet x and what? Y. Our start state is q0, we have q1, and then our accept state, which is what? q2. Now q0 on input of x should take us to what? q0. So as we saw over here, q0 on input of x, so q0, yeah, so as we said, q0 on input of x should loop, so it should still give us what? q0. And then q0 on input of y should take us to what? q1. So we have our q1 here. So if you have drawn the diagram, then you can follow along so that you can quickly complete the transition table. So q1 on input of x should take us to what? q0. q1 on input of y should take us to what? q2. q2 on input of x should take us to q0. q2 on input of y should take us to what? q2. Right, so this is the transition table and the diagram for set of strings that ends in what? Y. So this brings us to the end of our lesson for task 1. All right, so this is the task 2, right? So for the task 2, we have a diagram of a DFA, and we are to produce the transition table for the DFA that has been drawn, and then we are to minimize the DFA and then produce the transition table for the minimized DFA. So this is the question that we are coming to solve, right? All right, so for the transition table, we know that from the diagram we can see that the original DFA, so the original DFA has what? The state. So the states, we have Q is equal to we have Q0, we have Q1, we have Q2, we have Q3, we have Q3, and then we have what? Q4. All right, now Q0 is the start state, so Q0 is the start state, and then our final state or accepting state are what? Q1 and what? Q2. All right, so let's look at the transition table for the diagram. So the transition table. All right, so we have our transition function here, and then our inputs are what? 0 and then 1, and we already know our states, which is the start state is Q0. You have Q1, which is an accepting state. You have Q2, which is also an accepting state. You have Q3, and then we have Q4. So Q0 on input of 0 goes to what? Q1. Q0 on input of 1 goes to what? Q3. Q1 on input of 0 goes to Q1. Q1 on input of 1 goes to what? Q2. Q2 on input of 0 goes to what? Q2. So it loops. Q2 on input of 1 also loops. Q3 on input of 0 goes to what? Q1. Q3 on input of 1 goes to what? Q0. And then Q4 on input of 0, Q4 on input of 0 goes to what? Q1. And then Q4 on input of 1 goes to what? Q2. All right, so this is the transition table for the DFA. All right, so let's look at the minimization. So 2B, we are going to minimize the DFA. So the first step to minimize the DFA is to remove what? All unreachable states, right? So as you can see from the diagram, from Q0 we can reach what? Q0, we can reach Q1, we can reach what? Q2, and we can also reach what? Q3. But there is no way to reach what? Q4, right? Therefore Q4 is unreachable. So Q4 is unreachable, and therefore it is removed or eliminated. So Q4 is eliminated. All right, then we move to what? Step 2. So with the step 2, we do the initial partition. So the initial partition is to group the states that we have identified that we can reach from the start state into 2 states, right? So we have the final states. So you have the final states, which includes Q1 and then Q2. So those are our final states or accepting states from the diagram. And then we have the non-final states, which is what? Q0 and what? Q3. All right, so our initial partition, which is partition 0, is equal to Q1, Q2, and then we have Q0 and Q3. All right, so we are going to test for each partition and check whether they behave the same way or behave differently, so that we know whether we are going to split the states or we are going to keep them, right? So we test Q1 and what? Q2. So for Q1, on input of 0 goes to what? Q1. Q1 on input of 0 goes to Q1, yes. and then Q1 on input of 1 goes to Q2. So we have the set of Q1, Q2, and then Q2 on input of 0 goes to Q2, and then Q2 on input of 1 also goes to Q2. So we have the set of what? Q2. Right, so since Q1 and Q2 all go to what? Q1, Q2, which belongs to the same group, right, then it means that they all behave the same way. So the summary of this partition will give us what? Q1, Q2, right? So let's move to the next partition. So for partition 1, we still have what? Q1 and what? Q2. And then we have Q0 and what? Q3. So we test for what? Q0 and Q3, right? So test Q0, Q3. All right. So Q0 on input of 0 give us what? Q1. And then Q0 on input of 1 goes to what? Q3. So we have the set of what? Q1, Q3. Then Q3 on input of 0 goes to Q1, and then Q3 on input of 1 goes to Q0. All right, so we have the set of Q1 and Q0. All right, so let's check whether they behave the same way or they behave differently. So for Q0, Q1 is in the accepting state, Q3 is in the non-accepting state, right? So we have 1 here, 1 here. All right, then for Q3, Q1 is in the accepting, Q0 is in the non-accepting. So we can see that this Q0, Q3 also behave what? The same, right? So the summary of this partition, is also what? Q0, Q3. All right, so we can see that at the end of the day we have what? Our final partition, which is partition 2, which is what? Q1, Q2, Q0, and what? Q3. So we realize that after doing the first and second partitions, we still end up with what? 2 states, right? Meaning that if we keep on testing, we are still going to end up with what? These 2 states, right? Therefore, the DFA initially with 4 states has now been minimized to what? 2 states, right? So this is the minimized DFA. So let's say A is equals to the set Q1, Q2, and let B, so let A be equal to this, and let B be equal to the set Q0, Q3. Now, since Q0 is the accepting state, this B set becomes what? A. Since Q0 is the start state, then this set B also becomes what? The start state. And since Q1, Q2 are accepting state, then this set A also is what? An accepting state, right? So we can draw the DFA for this particular diagram. All right, so set A, start state. Now on input of 1, or let's start with input of 0. So on input of 0, where should this set A go? So you are going to use the Q0, Q3, right? Now for Q0, on input of 0 goes to what? Q1, which is in the accepting state, and then Q3 on input of 0 also goes to what? Q1, which is in the what? The accepting state. So we can say that since B is our accepting state now, A on input of 0 should go to what? B, which is what? An accepting state. All right, and then let's check for 1. So Q0 on input of 1 should go to Q3, which is in the same group, right? It's in the non-accepting state. And then Q3 on input of 1 goes to Q0, which is also in the same group, right? So you can see that Q1 on input of 1 loops itself. Now let's test for B. So the B on input of 0, let's look at that. So the B consists of Q0 and what? Q3. I've missed it now. Sorry. So let's A. Alright, so I think I missed that too. So let's do it again. So let A be equal to Q0, Q3, so that A is our start state. I want A to be our start state, right? I don't want A to be our acceptance state. That's why we are doing it like this again. So let A is equal to Q0, Q3, and let B be equal to what? Q0, Q1, Q2. All right. So what we did here was actually correct for A, right? But because we are starting again, I want us to do it again. All right. So A here, as we have seen, Q0, Q1, Q0, Q3. When we test, we see that on input of 0 goes to what? B, which is what? An accepting state. And then on input of 1, it loops itself. Now let's test for the B. Right, so the B, we are going to use Q1 and Q2. Now for Q1, Q2, Q1 on input of 1 goes to Q1, which is in the same group, and Q2 on input of 0 goes to Q2, which is also in the same group. So you can see that it loops for 0, right? And then Q1 on input of 1 goes to Q2, which is in the same group. Q2 on input of 1 goes to Q2, which is in the same group. So you can also loop for 1. So this is our final diagram for the 2 state. So now let's draw the minimize transition table, right? So we have our transition function. We have input of what? 0 and 1. We have our start state A, and then we have our final state what? B, right? So A with the input of 0 goes to what? B. With the input of 1 loops, so we have A. B with the input of 0 loops B. B with the input of 1 loops B, right? So this brings us to the end of our task 2. Yeah, so this is the task 3 diagram, and then we are to, so given the NFAs, the 2 NFA diagrams, you have to produce the transition tables for the NFAs. You have to use the state elimination approach and convert the NFAs to regular expression, and then we draw the resultant automata after each state was elimination. And then the C, you have to produce the transition table for each obtained automata after state elimination. And then D, you have to identify 3 strings that the first NFA accept, and describe the processing of the strings using the extended transition function. And then E, you have to describe the language of the first NFA using the was set builder notation. And finally, convert the first NFA into an equivalent DFA using the subset construction. All right, so let's begin with the first NFA. All right, so question 3A. Now let's identify our states. So we are going to call them NFA1 and NFA2. So we have NFA1 and NFA2. So let's begin with NFA1. So NFA1 has 3 states. So the states are what? Q0, Q1, and then what? Q2. Q0 is our start state, right? So Q0 is our start state, and then our accepting state is what? Only Q2. So Q2 is our accepting state. All right, so the transition table. So we have our transition function here. Then our input 0 and 1, and then we have our start state, which is q0. We have q1, and then we have what, q2. All right, so q0 on input of 0 goes to q0. q0 on input of 1 goes to q0 q1. q1 on input of 0 goes to what, q1 q2. And then q1 on input of 1 goes to what, q1. Then q2 on input of 0 goes to what, q2. And then q2 on input of 1 also goes to q2. So this is the transition table for NFA1. Then we move to NFA2. So let's do for NFA2. So for NFA2, our states are also q0, q1, and then q2. q0 is our start state again, and then our final states, we have two states, which are q1 and q2. Right, so with the diagram, we have our transition function here, and then we have our inputs 0 and 1, right? So our start state q1 is our acceptance state, q2 is also an acceptance state. I forgot to bring the acceptance state for this. So q0 on input of 0 goes to what, q0 q1. q0 on input of 1 goes to what, q1. q1 on input of 0 goes to q1. q1 on input of 1 goes to q1 q2. Then q2 on input of 0 goes to what, q2. q2 on input of 1 also goes to what, q2. So these are the transition tables for the first NFA and then the second NFA. All right, so we'll move to the second question, which is the state elimination. All right, so 3b, we have the state elimination. All right, so with the state elimination, there is actually a simple rule of thumb you can use to do the elimination, right? And the rule is that every new path should be equal to what, enter loop, and then anytime there is a loop, give it what, a star, and then concatenate what, the exit. So all you are doing is you are concatenating the enter, the loop will have a star, and then you concatenate what, the exit. So that is the rule of thumb that you are going to use. All right, so let's look at how we are going to do the elimination for the first NFA. So first NFA, or NFA1. Right, so with the first NFA, anytime we see 0 1, it converts to what, 0 plus 1, right? So we are going to redraw the first NFA, but then anytime we see 0, 1, we are going to put what, 0 plus 1, so that we can begin our what, our elimination, right? So we have q0. Now q0 loops, so it becomes 0 plus 1, and then 1 takes us to q1, which will also have, so this is 1, and then this will also loop 0 plus 1, and then this is 0, and then we have q2, which is an acceptance state, which is what, 0 plus 1. All right, so anytime we see 0 1 in the original NFA, we just convert it to what, 0 plus 1, then the rest we keep them as they are. Now since with the elimination we want from start state to what, accept state, we are going to eliminate what, q1, right? So eliminate q1. All right, So when we eliminate Q1, what do? We are going to use what? This rule of thumb. So how do we enter Q1? We enter Q1 with 1. Then when we get to Q1, we loop, right? So we are going to have 0 plus 1 star. And then we exit Q1 with what? With 0, right? So after eliminating Q1, our diagram becomes what? Q0 loops 0 plus 1, and then straight to what? Q2. So here becomes 1 concatenated with 0 plus 1 star concatenated with 0. So enter, loop, exit. That's what we are doing. Then we also loop on Q2, so 0 plus 1. All right. Now, and since we want to go from the start state to the what? Final state, we just concatenate everything to get what? Our regular expression for the first NFA, right? So regular expression 1 will be equal to what? Putting everything together. So anytime it loops, it is a star, right? So we are going to have 0 plus 1 star concatenated with 1, 0 plus 1 star concatenated with 0, and then our 0 plus 1 star. So this becomes our regular expression for the first NFA. And then let's look at the transition table. Now for the transition table for the first NFA after elimination, I'll use the from to approach, right? So we have the from to. Okay, so what this means is Q0 is the start state, right? So we want to go from Q0 to Q0, right? We want to go from, because we have eliminated Q1, right? So we only have Q0 and what? Q2 left, where Q0 is the start state and Q2 is what? The accept state, right? So now we can move from Q0 to Q0, and then we can move from Q0 to what? Q2. We can also move from Q2 to what? Q0, and then we can also move from Q2 to what? Q2, right? So let's look at what happens when we do each transition. So from Q0 to Q0, we can see that over here it was what? 0 plus 1. Now when we are doing the transition table, we don't bring the star, right? So Q0 to Q2, that's this one. So it will be 1, 0 plus 1 star 0. Then Q2 to Q0, there is no path from Q2 to Q0, so it's nothing. And then Q2 to Q2 is also just what? 0 plus 1. So this is the state elimination, the regular expression, and then the transition table after what? Elimination for the first NFA. All right, so let's move to the second NFA. Now with the second NFA, right? Yes, with the second NFA, Q1 and Q2 are accepting states, right? Accepting states. It means that there are two ways I can move from the start state to what? An accepting state. So from the start state to Q1 is accepted, and then from the start state to what? Q2 is what? Accepted, right? So in order to do the state elimination for this, the second NFA, and get a regular expression, what we are going to do is we are going to introduce what? A new final state, right? Where we can go there with what? Epsilon. So Q1 can get to the final state with what? Epsilon. And then Q2 can also get to the final state with what? Epsilon, right? So then we are going to eliminate Q1 first, then we eliminate what? Q2. All right, so first let's draw the original diagram and what it will look like, and then we start the elimination. And remember our rule: anytime we see 0, 1, it translates to what? 0 plus 1. All right, so the original diagram becomes what? Q0. So it loops 0. We go to Q1, which is an accepting state. So Q0 here is 0 plus 1. Then this one loops also 0 plus 1. Then we have the 1 here. And then we have Q2, which is also an accepting state. And then it will loop what? 0 plus 1. And since we are giving them a new final state, we can say, okay, this is the final state, and this is also the what? The final state, which is also an accepting state. Yes, so we have our epsilon what? Transitions. All right, so when you are drawing, we don't have to make, since we've introduced the new final states, then we don't have to make Q1 and Q2 what? An accepting state, right? So now the diagram will now become Q0, 0, then 0 plus 1 to Q1. Since we have a new final accepting state, Q1 and Q2 doesn't need to what? An accepting state anymore. So 0 plus 1, then we have 1, we have Q2, then we have loops 0 plus 1, then we have what? Epsilon, and then this is the final accepting state, and then we have what? Epsilon. So this is correct, and we don't want to do this. All right, so now we are going to eliminate Q1, and then when we finish, we are going to eliminate what? Q2, right? So let's start with the elimination. So we are going to look at the diagram and use it to do the elimination. All right, so we are going to eliminate Q1. So after eliminating Q1, it means that we can move from what? Q0 to what? Q2 from the diagram. We can move from Q0 to Q2, and we can also move from what? Q0 to what? The final state, right? Now from Q0 to Q2, we are going to concatenate everything that is here. Remember, enter, loop, exit, right? So from Q0 to Q2, enter, loop, exit. So Q0 to Q2 gives us what? 0 plus 1, 0 plus 1 star, and then 1. And then Q0 to F, right? We are going to have 0 plus 1, 0 plus 1 star, and then epsilon. But we don't need to bring epsilon. So Q0 to F gives us what? 0 plus 1, and then 0 plus 1 star. All right, so we can develop the from to table for this. So since there is no Q1, our diagram can look something like this. So we have our start state, so Q0, then we loop what? 0. Now we don't have Q1, so we move straight to what? Q2. So we can go straight to what? Q2. So when we move straight to Q2, when we concatenate, we are going to have 0 plus 1, 0 plus 1 star, and then 1, right? And then from Q2, we can move to what? The final state with epsilon. And then from Q0, we can go straight to what? The final state, which we use was 0 plus 1 and 0 plus 1 star. So 0 plus 1, 0 plus 1 star. All right, so we can do the from to table for the first elimination. So we have our from, and then to. Which states do we have? We have Q0, we have Q2, and then we have the what? Final state, which is the only accepting state. All right, so we can move from Q0 to Q0. We can move from Q0 to what? Q2. We can also move from Q0 to what? the final state, and you want to know what happens in each particular instance. So from Q0 to Q0, we have what? 0. From Q0 to Q2, we have this one. So 0 plus 1, 0 plus 1 star 1. And then from Q0 to F, we have this one. So we have 0 plus 1, and then 0 plus 1 star. Q2 to Q0, there is no way we can move from Q2 to Q0, so it's nothing. Q2 to Q2, yes, so there's Q2 to Q2. We forgot to loop Q2 to Q2. So Q2 to Q2 will give us 0 plus 1. And then Q2 to F is just what? Epsilon. So we'll bring there what? Epsilon. Then from F to Q0, there is no path. F to Q2, no path. And then F to F, there is no path at all. So this is the elimination of Q1, the diagram, and then the transition table after the state elimination. All right, so after eliminating Q1, remember we'll eliminate what? Q2, right? So eliminate Q2. All right, so remember what we have so far. So this is our diagram so far, right? So if we want to eliminate Q2, then it means that they are going to what? 2 ways to get to what? F, right? So here we'll add this one and get to F. So we move from here to here to here, or we move here to what? Here, right? So this is what we are doing. In fact, this part is very, very important. Okay, so it's like the right angle triangle, this one, right? So you want to move from point A to point what? C, right? So either you go from A to B and B to C, or move from what? A to C. So there are 2 ways, right? So A to B, B to C, or A to C. So either I'll move from Q0 to Q2 to F, or I'll move from Q0 to what? F. So once I eliminate Q2, then I have to account for what? The path, right? So there will be 2 paths. So either I use this path or this path, right? So when I eliminate Q2, I'm going to concatenate all this. I'm going to concatenate all this, right? So the path through Q2. So the path through Q2 will give us what? So let's look at this. So we are going to have 0 plus 1, 0 plus 1 star 1, and then 0 plus 1 star, right? So we are going to have 0 plus 1, 0 plus 1 star 1, and then we have 0 plus 1 star. All right, but then remember there was already a path from Q0 towards F, right? So you have to account for it. So already so direct path was what? So you have 0 plus 1, 0 plus 1 star. So the direct path was 0 plus 1, 0 plus 1 star, right? So now from our start state to the final state will be what? Either I use this path or what? I use this path, right? So that will be 0 plus 1, 0 plus 1, 0 plus 1 star, plus this one. So 0 plus 1, 0 plus 1 star 1, and then 0 plus 1 star, right? So now let's do the table, right? So we have from, and then 2. So we have eliminated Q2, right? So we are only left with Q0 and what? F. So our start state is what? Q0, and then our final state is what? F. So we can move from what? Q0 to Q0, and you can also move from Q0 to F. So from Q0 to Q0 will give us what? 0, right? Remember, q0, q0 loops. So q0 to q0 loops. But from q0 to f, that's what we have here. So we have all this. So we can see 0 plus 1, 0 plus 1 star plus 0 plus 1, 0 plus 1 star 1, 0 plus 1 star. All right, then remember, once we get to f, we can't go anywhere else, right? So from f to q0 is nothing, from f to f is nothing. Right, so finally our regular expression now, because on f we don't loop, right, but on q0 we loop, we have to start each with what? 0 star, right? So we are going to have this one, we are going to begin with 0 star here, and this one we are going to begin with what? 0 star. So for this one we are going to begin with 0, and this one we are going to begin with 0, because now we are including what? The start state. And because on the final state we don't loop or we don't do anything, there is nothing to put there. Right, so final regular expression will be 0 star, 0 plus 1, 0 plus 1 star, plus 0 plus 1, 0 plus 1 star, 1, 0 plus 1 star. So this is our second regular expression. All right, yeah, so remember we had something like this. So this would have been q0, and then it will loop 0, and then straight to what? To f, with this inside, right? So we have the 0 plus 1, 0 plus 1 star, plus 0 plus 1, 0 plus 1 star, 1, 0 plus 1 star. Yes, so we have q0 towards f, right? But then if we want to look at the two parts, remember we are adding two parts, right? So either we use this part and then this part, and all of them have what? A 0 star in front of them, right? So let's write the regular expression again. So r2 will be what? Assuming we are using the first part, then it will what? 0 star, this 0 star with a what? 0 plus 1, 0 plus 1 star, and then plus, assuming we are using the second part, right, then it will also be from q0 to f. You understand? So that will also be 0 star, then 0 plus 1, 0 plus 1 star, 1, 0 plus 1 star. All right, so that is it for the state elimination approach, the drawing of the resultant automata after each elimination. All right, so let's, and then the transition table for each obtained automata after the state elimination. So the next one, the D, is to identify what? 3 strings accepted by the first NFA. So 3 strings accepted by what? Accepted by the first NFA. All right, so let's identify the strings, right? So you can see, okay, the NFA accepts string 10, so the NFA accepts what? String 110, and then 3, the NFA accepts what? String 0101, right? So just to give a quick reminder of how the NFA can accept that string, let's draw the original diagram, right, and see how they accept this particular string. So NFA1, we have our start state, which is q0, which loops on what? 0, 1, and then on input of 1 goes to what? q1, which loops on what? 0, 1, and then on input of 0 goes to what? q2, which is an accepting state and loops on what? 0, 1, right? So when I give q0 1, now what can happen is we can either stay in q, yeah, so q2 loops on what, 0 1. All right, so now we want to know how this string can be what accepted, right? So for the 1 0, this is what can happen. We can loop 1 and then we can loop 0, right? So we can end in what, q0. Okay, now we can also, on the input of 1, we can go to q1 and then we can loop 0 here, so we can also end in what, q1. And then on input of 1 0, we can also have 1, and then when we get to q1, the 0 takes us to what, q2, which is what, an acceptance state, right? So for this 1 0, we can end in q0, we can end in q1, and we can also end in what, q2, right? And because we can end in q2, this 1 0 is accepted. So assuming we couldn't end in q2 and we could only end in q0 and q1, then this string will not be what, accepted, right? Right, so the same for the string 110. So I'm just going to focus on the where we can end in, right? So for 110, we can also end in q0, we can also end in q1, we can also end in what, q2. And since we can end in q2, it is what, accepted, right? And then for the second one, so that will be 1 and then 1 and then 0, right? And then the third string, we have 0 1 0 1, right? So you can have 0 1, then so we have 0 1 0 1, right? So it will end in what, q2, which is accepted. All right, so how are we going to use the extended transition function to process the strings from to see where they end in? Right, so let's take the first one. So string 101, sorry, string 10. So we are going to take the extended transition function from q0 to what, 10. So we are going to start with what, epsilon, right? So the extended transition function takes q0 epsilon, and that will give us what, q0. All right, then the extended transition function takes what, q0 and what, 1, and that will give us the transition function of q0 giving 1. And when q0 is given 1, we can stay in q0 or go to what, q1. So we can have q0 q1. All right, then we take the next one. So the extended transition function of q0 to 10. So you can have the extended transition function of q0 given this 0. So given 0 union the transition function of q1 given the same 0. So q0 given 0 will give us what, q0 union q1 given 0, can stay in q1 and can go to what, q2. So we can have q1 q2. So this means that the extended transition function from q0 to 10, right, will be q0 union q1 q2. So we'll end up in what, q0 q1 q2. And so like I said, because q2 is an acceptance state and it is part of the sets, the places where this string can end in, then it is what, this string 10 is accepted. All right, so let's process the next string. All right, so the next string is string 110. So we want the extended transition function that takes this string from the start state to 110. So we are going to do the extended transition function from q0 to epsilon, which is equal to q0. Then we are going to do the extended transition function from q0 to 1, which is equal to the transition function of q0 given 1. So q0 given 1 will give us what, either q0 or q1. So we'll end up with q0 or q1. Okay, then the standard transition function of Q0 giving 1 1. Alright, so this will be the transition function of Q0 giving 1 union Q1. Yes, transition function of Q1 given 1. Alright, so Q0 given 1 is Q0 Q1 union Q1 given 1 is still Q1. Okay, so when you join them together, you still have Q0 Q1, and then we do the standard transition function of Q0 giving 1 1 0. Alright, so that will be the transition function of Q0 giving what 0 union the transition function of Q1 giving 0. So Q0 giving 0 will give us what? Q0, and then Q1 giving 0 will give us what? Union Q1 Q2. So putting everything together will give us what? Q0 Q1 Q2, and because we have Q2 here, this string is also accepted. And then finally, our final string is what? String 0 1 0 1. Okay, so we are going to take the standard transition function from Q0 to 0 1 0 1 and see where we end up with. So we do the standard transition function Q0 given epsilon is Q0, then the standard transition function of Q0 given 0, right, is equal to the Q0 given 0 will equal to the transition function of Q0 given 0, and Q0 given 0 from the diagram will still remain at what? Q0. Then we move to 0, right? So we are done with 0. So the standard transition function of Q0 given 0 1, right? So we are going to have the transition function of Q0 given 1. Alright, so the transition function of Q0 given 1, Q0 when given 1 can stay in Q0, go to Q1. So we're going to have Q0 Q1. Okay, then the next one is the standard transition function of Q0 to 0 1 0. So we have the transition function of Q0 giving the 0 union the transition function of Q1 giving the 0. Alright, so Q0 given 0 will give us what? Q0 union Q1 given 0 can stay in Q1 or go to Q2. So we have Q1 or Q2. So we are going to have Q0 Q1 and what? Q2, and then finally we'll do the extended transition function of Q0 to 0 1 0 1. Alright, so that will be equal to the transition function of, so we are going to do for all of them, right? So I'm going to have Q0 given 1 union the transition function of Q1 given 1 union the transition function of Q2 given 1. Alright, so Q0 given 1, so Q0 given 1 can stay in Q0 or go to Q1, right? So we have Q0 Q1 union Q1 given 1. So Q1 given 1 will stay in Q1, right? So we have Q1, and then union Q2 given 1. Okay? So q2 given 1 will stay in q2. So we have q2. So putting everything together, that we're going to have q0, q1, and q2. All right, so this is the end of the external transition. Because it contains q2, which is an accept state, it is what? Accepted, right? And then the final one is the language of the first NFA. So the language of the first NFA. All right, so remember the format for the language, right? So the language is equal to the set of strings w, which belongs to the clean star, given the condition on what? W. All right, so we can see that the language of the first NFA, right, is equal to the set of strings that belong to what? 0, 1 star, right? Given that all right, so let's write it this way. So the language is equal to, so instead of using W, let's look at how we can write this. What do you call it? The language of this NFA. What do we identify? We can see that it contains what? 1 0, right? There's always a 1 0 in there. There is always what? A 1 0 in there, and there is always what? A 1 0 in there, and always the 1 comes before the what? The 0, right? Right, so we can see that, okay, we can have some x before the 1 and some y before the 0 and some z after the 0, right? So given that our x, y, z is inside what? Our alphabet, right, which is 0, 1 star. So I think this is much more easier to understand, right? So this is how our string will always look like, right? So some x can come before the 1 and some y can come after the 1. Now this x, y can be 0 combinations, right? So if x is 0 occurrence, y is 0 occurrence, z is 0 occurrence, but the 1 and the 0 must always be there, right? So we can have 1, 0. So there can be any number of strings before the 1, after the 1, and after the 0. But the 1 and 0 must always be present there. That's what this language says. All right. And we also have to convert the first NFA to an equivalent DFA. So first NFA to equivalent what? To equivalent DFA. All right. So let's look at the state of the first NFA. So NFA1, the states are what? Q0, Q1, and what? Q2. Right, and then we need to rewrite the transition table for the first NFA. All right, so we have our transition function. We have Q1, which is the start state, Q0, which is the start state, Q1, and then Q2, which is what? An accept state. So we have 0, and then we have 1. So Q0 on 0 goes to what? Q0. Q0 on 1 can stay in Q0 or go to what? Q1. Q1 on 0 can stay in Q1 or go to Q2. And then Q1 on 1 stays in what? Q1. Right. Q2 on 0 stays in what? Q2. And Q2 on 1 stays in what? Q2. Okay. So these are our transition table, right? So now we move to the subset construction. So to convert from NFA to DFA, so we perform 2 to the power n for the cardinality of the states. for the cardinality of the state of Q, where n is the cardinality. This is the cardinality. Right. So since the cardinality of Q is equals to 3, then we are going to have what? 2 to the power 3 states, which will be equal to what? 8 states. Right. So we had Q0, Q1, and then what? Q2. So breaking it down, we are going to have this. So we have the empty set. We have Q0, we have Q1, we have Q2, we have Q0, Q1, we have Q0, Q2, we have Q1, Q2, and then we have Q0, Q1, and then Q2. So we have 1, 2, 3, 4, 5, 6, 7, 8 states. Now since Q2 is an accept state, any state containing Q2 is also an accept state. And then our Q0 is our start state. Our inputs are 0 and 1. All right, so let's rewrite the transition table for this one. So here is Q0, Q0, Q1. We have Q1, Q2. We have Q1. We have Q2, and then we have Q2. Right. Sorry. So the empty state is supposed to be empty, right? Oh, so this is empty. This is empty. This is Q0. This is Q0, Q1. Then this is Q1, Q2. And this is Q0, Q1. Okay. Then this becomes Q2, Q2, right? So all we are going to do is we are going to combine them together for any two states that are combined. So for Q0, Q1, on input of 0, we combine Q0 and Q1, right? So that will give us Q0, Q1, and Q2. Then Q0 and Q1 on input of 1, we combine Q0 and Q1, right? So it's Q0, Q1, Q0, Q1. So this will be Q0, Q1. Then Q0, Q2 on input of 0. So Q0, Q2. So that will be Q0, Q2. And then Q0, Q2 on input of 1. So Q0, Q2. So that will be Q0, Q1, Q2. And then Q1, Q2 on input of 0. So Q1, Q2 on input of 0, we combine Q1 and Q2, right? So we have Q1, Q2. And then Q1, Q2 on input of 1, we combine Q1 and Q2. So we have Q0, Q1, and Q2. And then finally Q0, Q1, Q2 on input of 0, we combine these three. So Q0, Q1, Q2. So Q0, Q1, and Q2. And then finally Q0, Q1, Q2 on input of 1. So Q0, Q1, and Q2. So we also have Q0, Q1, Q2. So Q0, Q1, and what? Q2. Alright, so we draw the DF. So we start with the start state. So we have Q0 on input of 0 goes to what? Q0. So it will loop. And then on input of 1 goes to a new state, which is what? Q0, Q1. Alright, so this is on input of 1. Then we move to Q0, Q1. So Q0, Q1 on input of 0 goes to another state called Q0, Q1, and what? Q2, which is an accept state because of the Q2, right? That's on input of 0, and then on input of 1, it loops, right? So Q0, Q1, Q2 on input of 0, it loops, and then on input of 1 it also loops. So since there are no new states, this is the final DFA diagram for this equivalent DFA or equivalent NFA. All right, so that brings us to the end of task 3. All right, so this is the final task. So we have to convert the following regular expression to epsilon NFA. Then we are given this transition table. We have to state the transition diagram, the regular expression for the state diagram, and then we will ensure to show the regular expression conversion process on the state diagram. Then when we finish, we'll just identify 6 strings that are accepted by the machine. All right, so let's begin. So for the first one, we are going to convert the following regular expression into what? Epsilon NFA, right? So the first regular expression is what? 1 plus 0 star 0 into brackets 0 plus 1. All right, so with this one, right, we are going to use something called the Thomson construction rules from there. So we are going to use the Thomson construction rules, right? So what the Thomson construction rules says that there is a operator precedence that we are going to use, okay? And operator precedence is that star is greater than concatenation, which is greater than what? The union. All right, so what this means is that when we take this 1 plus 0 star 0 and then 0 plus 1 star, we always start from left to right. So left to right, right? So we are going to do the one with the star first. So we'll do 0 1 plus 0, then we'll do what? 1 plus 0 star, then we'll concatenate with what? 0. So then 1 plus 0 star concatenated with 0, then finally we'll do what? 1 plus 0 star concatenated with 0, and then concatenated with what? 0 plus 1. All right, so let's begin. Now this is what we are going to use, right? So for the star, we are going to draw a machine, right? So for example, assuming I have 0 star, then I'll draw it this way. So 0 0, so we give it what? A new, so this is a 0, right? So we give it a new start state and then a new accept what? State. We join the start state and a what? Accept state with epsilon. So this is also epsilon, epsilon, and then we join the what? This one to this one with epsilon. So this is what the star looks like. Then concatenation. So what does concatenation look like? So assuming I have 0 1, how do I concatenate it? So I have so this is my 0 and this is my 1. So all I have to do is join them with what? The epsilon. Remember, I'm moving from what? Left to right, right? So the 0 has the start state, and then this one will have the what? The final state, and then we join it with what? Epsilon NFA, right? So you can even give them some boxes to show the individual this one. All right, then if we have 0 plus 1, then how do we draw 0 plus 1? So this is our 0 and then this is our 1. So what happens is we give it a new accept state. We join it with what? Epsilon. Remember to bring the arrows, and then we give it what? A new start state joined with what? Epsilon. All right, so this is how we are going to do what? 0 plus 1, right? So now let's begin. So for the I, we have 1 plus 0 star star 0, then 0 plus 1, right? So first we'll do 1 plus 0. So this is our 1, and this is our what? 0. Right, and because we start from left to right, we give it what? A new start state joined with what? Epsilon, and then we give it what? A new state. But since we are not at the end yet, this cannot be the accept state, right? So this is epsilon. So this is 0 plus 1. So this is 0 plus 1, but we have to do the star. 0 plus 1 star. Okay, so let's do it this way. So let's redraw this same thing here so that we can have enough space to do the star. So let me do it this way. So 1, 0, and then so epsilon, right? So with a star, it means we have to give it what? A new start state and a new what? Accept state, right? So 2 new states. Right, then we join the start state to what? The accept state, like this, and then we join this one to this one, like this. So this is 1 plus 0 star. Okay, so we concatenate it with what? With 0 using epsilon. So this is our 0. Then finally we concatenate it with what? 0 plus 1. So this is my 0, and this is my what? 1. And then I join, and then this will be my accept state. So this is my 1, this epsilon, and this epsilon, this epsilon, and this epsilon. So I do my arrows. Yes. So this is 0 plus 1 star concatenated with what? 0 concatenated. So we have to do another concatenation here. Actually. So we didn't bring the concatenation, so let's do it again. All right, so let me use this space so that we can have enough space to do it. So we are doing 1 plus 0 star 0 plus 1. So let's do 1 plus 0. So this is 1 plus 0, so 1 0. So this is 1 plus 0. Then we do the star. So we bring the star. So we give it 2 new states. So it's the star state. Then we join from the start towards this state, and then we join from this state to this state. All right. Then we concatenate with what? 0. So this is 0, right? Then we concatenate with 0 plus 1. Right, so concatenated with 0 plus 1, right? So this is our 0, 0, join this to this, and then we give it the final accept state. So this is 0 1 epsilon, 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 so epsilon, 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 epsilon. Then our arrows, very, very important. All right. Okay, so this is 1 plus 0 star 0, 0 plus 1. So let's move to the next one. So the next one is what? 1 0 star 1 plus 0. So we do the one with a star first, right? So we do 0 star, concatenate with 1, concatenate with 1, and then we union it with the what? 0. So let's do 0 star. So this is 0 star. So this is 0. Give it a new state, right? Join the stars to the end state, and then join this one to using epsilon. Okay, then we concatenate it with 1. So epsilon, this is 1. And since 1 begins, we give 1 the what? the star state, right? Okay, then we concatenate with another one. So we have another one here. Right, so we union it with what? 0, right? So you can have 0 here. Then remember the rules of the 0. We give it a new start state, right? Epsilon, epsilon, and then we give it what? A new accept state. So the arrows are important. Epsilon, epsilon, and then this is the new start state. All right, so this is 0 star concatenated with 1, concatenated with 1 here, then union this 0, right? So this is 1 0 star 1 plus 0. So let's move to the next one, which is what? 0 plus 1 0 star plus 1, right? So first move to the left before we go to the right. So we'll do 0 star, concatenate it to 1, union it with 0, and come and union it with what? 1, right? So what is 0 star? So let's do 0 star, right? So 0 star, it means that you have to give it what? 2 new states. Join this one to this one, then join this one to this one. So that's 0 star. Concatenate with 1, 1. Then we have to union it with what? 0, right? So we are going to have a new state here, and then we have a new accept, new start state here. Okay, then we union this with 1, right? So we have another 1 here, then we give it a new start state, and then a new accept. So this becomes our accept state, and this is our start state. So this is 1, this is what? 0. Be at the top. So this 0 has to be at the top. You understand? This 0 has to be at the top. So now let's do the arrows. And now our epsilon. Alright, so this is 0 plus 1 0 star plus 1. Okay, so the next one is what? 0 star 1 into bracket 1 plus 1, right? So first we do 0 star, concatenate to 1, concatenate with what? 1 plus 1. So let's do 0 star. So this is the new start state, new accept state. Join them together, join this one together, concatenate with 1 epsilon. This is 1, then concatenate with what? 1 plus 1. So this is 1 1, join them together, and this one has the what? The new accept state. So we have epsilon, 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 epsilon. So epsilon, 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 epsilon. Wow. Yeah, so this is 0 star, concatenated with 1, concatenated with what? 1 plus 1. And then we have what? So we have 1 0 star 0 plus 1 what? Star, right? So do 0 star, concatenate with 1, concatenate with 0, and then union it with what? 1 star. So let's do our 0 star. So this is 0, give it a new, 2 new states, join them together, concatenate with what? 1, give it there, concatenate with 1, okay, give it a new start state for now. So this is epsilon, 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 epsilon. So this is our 0. Then we join it with, concatenate it with 0 here too. So this is our 0. Then we union it with 1 star. So let's do 1 star, right? So this is 1, and then we give it 2 new states, join them together. So this is 1 star, and then we join this one together, right? So we can have this one. So this is a star state, right? And this one comes here. So we do the arrows, and then we'll have a final accept state. So epsilon, 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 epsilon. Yeah, this one is this one what? This is 1, not epsilon. This one. So this is 0 star concatenated with what? 1, concatenated with what? 0, and then union with what? 1 star. Okay, so that's it. Then we go to the next one, which is what? 0 plus 1 concatenated with what? 0 plus 1. So 0 plus 1 concatenated with what? 0 plus 1, right? So we need a 0 plus 1. So this 0, this 1. So you'll have a new start state, and then a new accept state. Then we concatenate it with what? Another 0 plus 1. So this 0, this 1. So this become our what? Accept state. Then bring the arrows to show our direction. Alright, so epsilon, 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 epsilon. And then our final diagram is what? 0 plus 1 star. Alright, so we first do 0 plus 1. So this 0, this 1. So give it the new start state, new accept state. Then the star says that would give 2 new accept states. So we give this a new start state and a new accept state, and then we join the star state to the what? Accept state, and then we join this one to this one. So this epsilon, 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 epsilon. So this is 0 plus 1 star. And then we have epsilon, we have epsilon, the other one, so we have epsilon. Yeah. Okay. Alright, so these are the diagrams. Alright, then we move to the table. So for B, so they say given the transition table, we have to produce the state transition diagram, right? So let's do the transition table. So we have A and what? B, right? So K0 is a start state. You have K1, K2 is an accept state, K3 is also an accept state. K0 on input of A goes to K1, K0 on input of B goes to K2. So this is K0, this is K2, this is K1, and then this is what? K0, K3, and this is what? K3. Alright, so we'll start with what? K0. So K0 on input of A goes to what? K1. And then K0 on input of B goes to what? K2, which is an accept state. Okay, so K0 on input of A goes to K1, on input of B goes to what? K2. Then K1 on input of A goes to what? K0. And then K1 on input of B goes to what? K2. And then K2 on input of A goes to what? K1. And then K2 on input of B goes to what? K0. Alright, then we have K3, which is also an accept state. But then K3 on input of 0 loops. On input of A, it loops, and on input of B also what? Loops. So this is the state transition diagram for this. Alright, then we have to do the regular expression for the state transition diagram. Alright. Alright, so let's begin the state regular expression. So for B, so for BI. Alright, so regular expression by state elimination. Alright, so for the DFE, in order to find a regular expression, we need to add a new start state, and then we need to add a new final state, right? So we are going to have K1, K0, and K2 being in the middle, right? So it's going to look something like this. So S to K0 with epsilon, and then we are going to have K2 to the final state with what? Epsilon, right? So our new final state is going to be what? K2. And then we are going to eliminate in this order. So first we eliminate K1, followed by what? K0, followed by what? K2. So that's how we are going to do the elimination. Alright, so let's start with the elimination of the diagrams of the state. So we're going to eliminate K1. Alright, now when we eliminate K1 for the DFE, there are 4 ways to eliminate K1. Remember our rule of thumb when we are doing state elimination, right? So our rule of thumb is that we enter, we loop with star, and then we do what? We exit, right? So the question is, in how many ways can we enter K1 and exit what? K1, right? So that's what you're asking. So there are 4 ways. Okay, so we can do okay, K0 to K1 back to what? K0. That's one part. So K0 to K1 to K0, that's AA. So from K0 to K1 is A, from K1 to K0 is what? A. That's the first part. Another way we can also enter is what? From K0 to K1 to what? K2. So from K0 to K1 is A, K1 to K2 is what? B, right? So that's the second part. Then the third part is what? K2, right? So we can do K2 to K1 to K2. So K2 to K1 to what? K2, right? So K2 to K1 is A, and then K1 to K2 is B, right? and then finally we can do k2 to k1 to what? K0. So there are 4 different ways we can enter k1 and exit k1, right? So k2 to k1 is a, and then k1 to k0 is also what? A, right? So we are going to identify all those parts. So k0 to k1 to k0 will give us what? A. K0 to k1 to k2 will give us what? AB. And then k0 to k1 to k2 will give us what? AB. And then k2 to k1 to k0 will give us what? AA. Now, from k0 to k2, there is a direct path, as we can see, right? We can move from k0 to k2 straightforward. So k0 to k2, we can also add this part. So we can say, okay, AB plus what? B, right? And then we have a straight path from k2 to what? K0, right? So from k2 to k1 to k0 is AA, and the straight path is what? B. So we can say, okay, AA plus B, right? So if we want to eliminate k1, then we must account for what? All these parts. Do you understand? All right. So we can say that k0 to k1 to k0 is equal to k0 to k0, which is a loop. Okay, and also k2 to k1 to k2 is also equal to k2 to k2, which is also what? A loop, right? So this the first loop is what? AA, and then the k2 loop is also what? AB. So now when we are drawing, if you want to draw the diagram, then it's going to look something like this. So we are going to have from our new start state to what? We don't have k1, so to k0, and k0 loops, right? So k0 loops AA. Okay, then from k0 we'll move to what? K2, because there is no k1, so k2. So from k0 to k2 we have AB plus what? B. So we have AB plus B. And then we also have from k2 will also loop, right? So k2 also loops AB. So here is AB. We also have from k2 to k0, k2 to k0, which is what? AA plus B. So this is AA plus B. And finally, epsilon takes us to what? The final state. All right. So now we can draw the table after eliminating what? K1. So remember our from to table. So what state we have? We have our start state, we have our k0, we have k2, and then we have what? The final state. We can move from the start state to what? K0. We can move to k2, and we can also move to what? The final state. All right. So from start state to k0 is epsilon. Start state to k2 is not possible. Start state to the final state is not possible. K0 to k0 is a loop, so it's AA. K0 to k2 is what? AB plus B, right? K0 to F, we don't have k0 to F, so it's not possible. Then we have k2 to k0. K2 to k0 is possible, so AA plus B. And then we have k2 to k2, which is a loop, so AB. We have k2 to F, which is also what? Epsilon, right? Then we have F to k0 is not possible. F to k2 is not possible. F to F is not what? Possible, right? Because we only enter F. So this is the first elimination of what? K1. So next we eliminate what? K0. Okay. Now if you are eliminating k0, then remember there is a loop on what? K0. So k0, the loop on k0 is AA. So when we eliminate k0, the AA becomes what? AA star, right? So AA becomes what? AA star, right? So now the new path, new path from our S to K2, right? Because we are eliminating K0, you have to concatenate this AA and AB plus B, right? So the new path from S to K2 will be equal to what? Remember there was epsilon, right? So we have epsilon into bracket AA star into bracket what? AB plus B. All right. So remember epsilon is an empty string, so you can rewrite this as what? AA star AB plus what? B, right? So now this is our S to what? K2. So once we eliminate this K0, S to K2 will be straightforward this, right? Now also K2 will loop because we can go to K2 can go to K0 and then back to what? K2, right? And remember we can have what? K2 to K0 back to what? K2. And we know K2 to K0 is what? AA plus B. And then from K0 to K2 is what? AB plus B, right? So now the loop on K2 will now be what? Now when we get to K0, it loops, right? So we are going to have what? AA plus B. When we get to K0, it will be what? AA star and then concatenated with what? AB plus B. So we have to put the AA star here. Yes, that's from K0 to what? K2. You understand? All right. So now this is how the diagram is going to look like. So you are going to have S to K2. So you have this. So I'm going to have S straight to what? K2 straight to what? F. So S to K2 will be what? AA star. We have into bracket AB plus what? B. And then the K2 will be what? AA plus B concatenated with AA star and then concatenated with what? AB plus B. That's the loop on what? K2. And then epsilon takes us to what? The final state, right? So finally, okay, and also K2 already had a loop AB, right? So we can add the AB to this one. So this loop is supposed to be accounted for together with a new loop that has been generated for it, right? So the loop on this will be what? K2 to K2 should be AB plus AA plus B concatenated with AA star concatenated with what? AB plus B, right? So now the final regular expression for the DFA will be equal to what? Remember, we are concatenating everything together with the epsilon, but we don't need the epsilon now, right? Yeah, so we are going to have AA star concatenated with AB plus B and then concatenated with what? AB plus AA plus B concatenated with AA star concatenated with AB plus B. So this will be the final regular expression. All right, then the final question, that's 4B I. Right, we are required to write down 6 accepted strings by the what? DFA, right? So from our diagram, we can see B is accepted. So let's look at the diagram. So we can see from K0 to K2 is B, right? So B is accepted. We can also see A, B, right? So we give K0A, and then we give it B, and it takes it to what? K2. Okay, so AB is accepted. And then we also have what? AAB, right? So we give K0A, give K1A, and then we give K0 what? B, which takes it to the accept state. So AAB is also accepted. And then BAB, so we give K0, we give it B, and then we give K2B, and then we give K0 what? B again. It ends up in K2, which is accepted. And then we can say BBB, right? So we can give K0B goes to K2, give K2B comes to K0, and then give K0B again. So BBB is also accepted. And then finally ABAB will be accepted. So K0 we give it A, and then we give K1B, right? That's AB. And then we give K2A, goes back to K1, and give it B, ends up with what? K2, right? So let's rewrite them formally. So the first one, we can say first one, B is accepted. That's from K0 to K2, B. Then the second one, we can say AB is accepted, right? Because we can give K0A to take it towards K1, and then give K1 the B to take it towards K2. So once we are ending at K2, it is what? Accepted. And then 3, we can say what? AAB is also what? Accepted. AAB is accepted. So give K0A to take it towards K1, and then we give K1A to bring it back to K0, and then we give K0B to take it towards K2. So it's accepted. Fourth one, BAB. So we can give K0B, which takes it towards K2, and then we can give K2A, which takes it to K1, and then we give K1B, which takes it towards K2. Therefore, it is accepted. Alright, then the fifth one, we have BBB. So we give K0B, it takes it towards K2. We give K2B, it takes it towards K0, and then we give K0B, it takes it towards K2. It is accepted. And the sixth string is what? ABAB. So ABAB. So we give K0A, it takes it towards K1, and then we give K1 the B, it takes it towards K2, and then we give K2 the next A, it takes it to K1, and then we give K1 the B, it takes it towards K2. Alright, so the 6 strings that are accepted are what? We have B, AB, AAB, BAB, BBB, ABAB. Alright, so this is the conclusion of the midterm assignment from tax 1 to tax 4. Thank you.